Welcome back, everybody. Mr. Cowan here to help you with a lesson on circumference. It's really 10-10 in our textbook. I'll call it 10A1. But we're going to go ahead and pause the video, check your answers from the previous assignment. Come on back when you're ready, and I'll just scroll down as we go. Again, if you need to rewind, check some answers, bring some questions for the next day. You know I love questions. And here we go, where we have been looking at area and perimeter of polygons. That, of course, are shapes with 3 or more edges. And of course, if they have edges, they also have vertices. And we can find the perimeter or distance all the way around. But you cannot find the perimeter of a shape that has no edges, like circles. So, twofold objective today. Number one is understand the relationship between radius and diameter. That's more of a conceptual understanding, although if you're given one, you should be able to find the other. And number two, calculate the circumference. Eventually, we're going to move from two-dimensional figures into three-dimensional figures, but for now, let's focus on two-dimension. Go ahead and pause, whatever the date, whatever the assignment number. Come on back when you're ready. All right. I'm wondering how many of us really understand what a circle is. Often I hear people say, well, it's a round shape, and so I draw this. And they say, well, it's more like a egg. Okay, no, that's an oval or ellipse. And they understand what a circle is, but they cannot define it. So here we go. A circle is, by definition, in a round plane. A circle is any number of infinite points. It's a shape that consists of infinite points that are equidistant from a fixed point, and we call that the center. So literally a circle is an infinite number of points. Like when I say infinite, I mean infinite. You come up with 2 points, I'll put one in the middle. You come up with those 2 points, I'll pick one in the middle. You take a magnifying glass and take those 2 points, and you can keep going forever. So instead of sitting here and drawing infinitely many points, we often just draw what appears to be not points at all. But that is what a circle is. It is an infinite number of points, all of which are equidistant from a fixed point. No center, folks, there's no circle. So every time you draw a circle, you really should draw that center point. Now, perhaps you already realize that distance is often described as the radius. Actually, radius is more the line segment connecting the center of the circle to any point outside, which naturally means that each and every radii has an equivalent length. All right, but what if the line segment goes through the center and all the way to the other side? Now, let's be clear, a chord is a line segment connecting any 2 points on a circle. The longest possible chord is called a diameter. So, a diameter of a circle is a line segment which intersects the center point and has an end, actually you could say 2 endpoints that lie on the circle. Naturally, what that means, ladies and gents, is if from the center to the outside is one radius, then I suppose an equidistant line segment would mean another radius. So we could say the relationship of a diameter to a diameter is the same as saying radius plus another radius, or perhaps you would rather say 2 radii. What if you want to go the other way? What if, in other words, you want to get rid of that 2 and have it say r equals? Well, you could get rid of the 2 by cutting it in half, and therefore find that if you have the diameter, you simply have to, well, I don't need to cross that off, I guess, but if you have the diameter, you could cut it in half to find the radius. If you have the radius, you could double it to find the diameter. And that, ladies and gents, is already half of our objective, understanding the relationship between a circle's radius and its diameter. All right, so what is this mysterious word circumference? Well, as I said, you can find the perimeter of a polygon if you can measure all the lengths of each and every edge. But circles have no perimeter. Thus, that's why I put that in quotation marks there. The circumference of a circle is really the length measuring around the outside of its shape, around the circle. Now, this is interesting because the ancient Greeks found a special relationship. And by the way, a lot of mathematics will go back to the ancient Greeks and what they studied, but they're not the only ancient civilization that was learning math long before there were computers and calculators. China, ancient India, even parts of Africa, ancient Egypt, for instance, they all were starting to learn about this mysterious number, well, mathematics, the study of numbers and all sorts of things around us in the world. So circumference, what they did was they kept measuring the outside of a circle, its circumference, and they compared it to the diameter. They looked at the ratio, and it's such a weird thing that every time they did that, no matter if it was a big circle, a small circle, it kept dividing to the same amount. To add more mystery, this amount that it would divide to, it kept going and going and going. In other words, it had no end. And they found this so fascinating, and it existed all across circles, across the world, that they just said, we're going to just give this a letter to define what that relationship is. Therefore, folks, that is why they used a Greek letter of pi. So the letter pi is not just a number, it is more a relationship. It's the relationship of a circle's circumference compared to its diameter. Now, what if I want to have an equation that simply says D equals? If you want to get rid of that divided by C equals, excuse me, if you want to get rid of that divided by D, then multiply both sides by D. The inverse of division is multiplication. And of course, you have to be fair and do the same thing. And when that happens, we now have a lovely relationship. If you don't want to just look at a ratio, if you want to look at an equation of circumference equals, it is pi times its diameter. I'm going to go ahead and erase that. If you need to, pause the video, rewind where that relationship came from. All right, Mr. Callan, but what if we don't have the diameter? What if we only have its radius? Well, naturally, a diameter, you could say, is 2 times the radius. Now, I wish they would have written that, but for whatever reason, we use the commutative property. They switch it, and they call it 2 times pi times r. But here is perhaps the most important part of today's lesson. If you want to find the measurement of a circle's circumference, use either one of these equations or formulas to do so. The circumference is equal to pi times its diameter, or if you would rather have if you have a radius, then instead switch that to circumference is equal to 2 times pi times radius. Go ahead, pause the video if you need to write those down, but that should be the most important part that you learn at the top of your paper. Now let's go ahead and we're going to find a few examples of circumference. And by the way, if you noticed earlier on, it said write all 4 lines. I will explain that coming up, okay? All right, so first we have what it looks like a compact disc, but wait a second, no CD is only 15 inches. Maybe this is more of a record, I don't know. But we do have what appears to be the diameter. That's all the way across. So the first thing I ask myself is, which formula am I going to use? Well, we have its diameter. Let's stick to that formula. Circumference equals pi times diameter. Next, what we can do is we can substitute in that particular number. And in this case, the diameter is 15 inches. Thirdly, I'm going to go ahead and put the 15 in front of the pi. You may choose to put the dot. You may not put the dot. That's up to you. And then I'm going to ask myself, what is it we're measuring? Are we needing inches, inches squared, or inches cubed? Well, in this case, I really just want a circumference. In other words, I'm measuring the distance all around the outside. So if you put a string around a record and then you laid it flat, that is one and only one dimension. Ladies and gents, the units here would simply be inches. I don't think students usually write inches to the first power, but you can if you want, because it is a one-dimensional unit. Now there's one piece left. While we just found a great answer, Oftentimes, people will estimate it, knowing that pi is an irrational number. It goes on forever, it does not terminate, and it does not repeat. I'm going to go to our lovely Desmos calculator, and I'm going to type in 15. Now, pi is a lovely button right here, or you can actually just type in pi, and the programming will automatically change it to pi. In this case, 15 times pi is 47.1238898, and the chances are very high that if the calculator goes that many digits, it will go on and on and on and on and on. Let's go ahead and round it to the nearest thousandths place. So I look at the 12 and I ask myself, is that going to be closer to 12 hundredths or 13 hundredths? And I notice the 3 at the end. So I do believe that will be closer to 12 hundredths. So I'm going to go ahead and write that. 47 and 12 hundredths inches. Now, if a student were to ask, would you rather have 15 times pi dollars or $47.12? You're going to say, look, those are pretty much the same numbers. But if a student asks, well, which answer is more precise? Which answer is more exact? That is clearly the 15 times pi. Because 15 times pi is our exact answer, whereas 47 and 12 hundredths is a pretty stinking close good approximation. Now at this point, I want you to notice the four lines that I'm expecting for the homework. Line number 1 is to figure out which formula to use. Line number 2 would be to substitute in the number. Line number 3, simplify by putting the numbers in front of the pi. And line number 4 is to calculate it and then round it to the nearest hundredths. Don't forget our units. We're not talking square or cubic inches. We're talking simply inches around that piece. Onward we go. This one is not a real world problem. I'm going to write down the 4 lines and then say, okay, hold on. What is given to us if we'd like the circumference? Well, wait a second. In this particular case, they give us not a diameter, they give us a radius. So I'm going to go ahead and use the formula 2 times pi times r, in which now we may substitute in for the radius, which we know to be 5 centimeters. Now at this point, I don't see any reason why we'd write 2 times pi times 5 when we could simply write 10 pi. And then of course, I will go over to our Desmos calculator. We're gonna have to multiply 10 times pi, rounding it to the nearest hundredth. So once again, you can use this button right here or type in pi. And we get an answer of 31 and 41. Okay, now wait a second. Some students have pointed out in the past, Mr. Callan, there's a 5. So does that mean that both are equidistant? Well, it's true that 5's in the middle, but if there's other digits, it's going to lean up. So technically it is closer to 42 hundredths. 31 and 42 hundredths, I shall write. And we're not measuring square or cubic centimeters. We're simply saying how many centimeters are there. Notice we have 2 answers. One is exactly 10 centimeters and the other is pretty stinking close. Now for the record, I could have used the other formula, and I didn't show this in class previously, so I'm going to show it right now. What if, instead of using 2 times pi times r, I still want to use this formula every time? Well, you can't. Well, let's actually find out what happens. If I write here, oh, wait a second. So 5 is not the diameter. If 5 is a radius, and we have another 5 that's a radius, that means the diameter is going to be 10. So I have to make sure to put that 10 in its place. Now, of course, if I write the coefficient in front of the variable, actually it's not a variable so much as a quantity, 10 times pi, and then if I went to the calculator, what do you notice about your answers, ladies and gents? Of course, these are the same. But what you cannot do is accidentally insert, say, 5 in place of the diameter, because that would be incorrect. There is a difference between 10 times pi and 5 times pi. Those are not the same. So theoretically, you could use either formula. Make sure you understand, do you have the radius or do you have the diameter, and use that appropriate quantity. All right, do one more. I'd encourage you to pause your video, come on back when you're ready. So we really want to find out how far this bike travels. If you think about that bike tire will go all the way around. Imagine now stretching that out. How far will that bike go? Well, essentially, this is a diameter problem. So, excuse me, a circumference problem. So go ahead and decide which formula should we use, even though we already said you could use either one. What I notice is the diameter is given to us, and you could even include that in your drawing if you wanted. Okay, so I'm going to use the first formula, substituting 2 feet for the diameter. I'm going to rewrite it with 2 in front of the pi. And then I'm going to go to the calculator, type in, and I know the textbook is going to say use 3 and 4. No. That was way back when, before they had a really nice pi button on calculators. 2 times pi, 2 times pi. 6 and 28 or 29 looks closer to 28 hundredths. So I'm going to write 6 and 28 hundredths of a foot. Well, I guess I should say feet. And again, you may find the same answer as long as you say, oh, wait a second. In this case, the radius would not be 2 feet. The radius would only be 1. And you're still going to get the same answer. So, in summary, pause for a second and see if you can do both numbers 1 and 2, and come on back when you're ready. Again, anytime you draw a circle, make sure you draw a central point. Do you understand? Can you describe the relationship? Well, one radius is from the inside to the outside. 2 radii, by the way, that's plural for radius, radii. 2 radii is what makes a full diameter. If you have a diameter, you can cut it in half to make a circle, to make a radius, and if you have a radius, you can double it to find the diameter. Keywords that could let you know you're looking for some circumference. You could find words all the way around. You could find exterior. You could say, how much would you walk a path around an object? So think about keywords like that, and if you have any more, add that to your list. Again, no matter what the date, no matter what the assignment number, make sure that you show all 4 lines to each and every problem. If you're in class with me, we're going to do these couple together or with your partner. So you should have 2 answers, an exact answer that still has a pi, and an approximate answer. Don't forget your units. You're not talking yet square feet or cubic feet. You just want to know how many feet would it take to go around this circle. So go ahead, continue on with your homework. Do well, folks. See you.